So hello everyone, welcome back to the channel. And in this video, we'll do a load testing of my website. So I have a website. So if you can see my screen, this is a very basic Notepad application, online Notepad application. So if you come to this website and click on Create Notepad, it will open a Notepad which you can share obviously, and maybe lock it with some passwords and everything. And it has some real time stuff also going on. So if you whatever you type in and open it in a new tab also, you will see all those changes it taking effects immediately. So here it is edited. Now what I'll do is I'll just do a load testing on this website using Locust. So Locust is a basically open source load testing tool in Python. It provides a GUI facility where you can we can define our parameters and test it, and the endpoints and everything, payload for post request, those things we can define through code. So basically, I have this website hosted on a Oracle server. So the server configuration is basically like it's an single core server, but since hyperthreading is enabled over there, so it gives basically two cores, you can say. Yeah, mostly that is the configuration, and I think 1 GB of RAM only. So nothing too fancy over there. So what we'll do is we'll do a load testing for this and try to simulate a real users basically. So what I'll do is I'll open up the editor. Now what you can do is you can install the package first. So it's just pip3 install locust. That's it. So I have already installed it, so I will not install it. Now if you look at the code, it is basically what I am doing is I am just defining a user instance which inherits from this HTTP user, and this wait time is basically to basically demonstrate like what is the wait time between each task. So here I have defined each of tasks. So task you can think of like first the user will go to the home page, then click on a button. So in this case it will click on this create instance, create notes button, which will open the notes instance, and then maybe type something. So when they type something, it will send a payload to the server. So this will basically post request. So all these three endpoints, whatever are the actions we are doing, this is basically to simulate a user's actions. So between each action, we want to have some time. So in we can think of it in a real time scenario that you may take some time. So here I am defining the wait time to be between somewhere between 1 and 3 seconds. So again, this task 3 is like highest priority. So if 100 users are coming to my website, so that means not all of them will click on the create notes or maybe type something. So that's why I have the highest priority given to the first one, homepage, and the second priority to create notes and type in something, that is to save some notes. So this is overall load testing code. Now what I'll do is I'll just go through the server. So if you see, I'll show you the number of cores. So it's basically two, just because of hyperthreading. Now what I'll do is I'll basically open my terminal here and show the statistics. So right now you can see 686 memory is being used, and two cores are free, almost free. So now what I'll do is I'll just this is the file locust dash app locust file. This is the file name, and my host is basically the domain name, my domain name. So I'll start the server and pull up the browser. So I just minimize it. Okay. Now if I refresh, so here you can see this is the web page. Now what I'll do is we can check the statistics over right side. So first of all, I'll start with maybe 10 users, and each second will increase it with one user only, and maybe run it for 60 seconds. So 60 seconds is too much, maybe 20 seconds. So if I start the process, what it will do is it will now send the requests. So I'll just fast forward it every time. You don't have to wait for much long. So now the load testing is completed, and we in total we sent 56 requests. The first home page we sent 23, the second one we sent 16 and 17, almost similar for the second and third request, third endpoint. And we can see average response time is 116 millisecond, which is very good, and we don't have any failures. And I think everything seems good because we have very less load now, and current request per second is 3.9. Let's just edit it and increase the maybe the number of users to 50, and every time just let's increase by 10 and update it. Okay, now we can see a little bit more request going on. And the next one, I'll probably increase the time also. Here you can see the CPU usage is increasing. Um, Currently it's almost 20, 30. Yeah. Okay, so now our second run is completed, and in total we sent around 1200 requests. And if you see now, still the average response time is 113, and 95 percentile of the request is completing under 220 millisecond, and maybe 99th percentile it is going to 420. Not a very big difference still. And our current RPS is 23.4 and no failures. So now let's increase it maybe. I'll do a new test, and maybe this time we'll increase it to 100. Then increase in 10 users per second, and run it for 60 second. Oh, let's start it now. Also, one more thing we can do is you can come over to this chart section and look at the charts. So this is the first run, this is the first run, then again second run, like this it will show you. So first run you can see it kept on increasing the RPS, and if you come to the below, it will show you the users. So gradually the users will start increasing, and then at one point it will come to a steady point. So once your limit is reached, so the second run is running now. I can see right now it has reached peak users of 100. You can see the CPU spiked up to almost 100% now, both the cores, and memory usage is still the same average. Memory is not a issue over here. Let's wait for some time. Okay, so now our test is completed. So in total we sent 2051 requests, and I can see the still the average response time is 657 millisecond, which is I think very good considering our server capacity, and still no failures. And yeah, I think all good. Now let's increase it a little bit more, maybe try 150, and ramp up users. 20 users per second we will ramp up, and same duration. I'll start it. You can see the CPU spiked up again. Okay, so now it's completed. So in total we sent 2000 plus requests, and now there is a little delay now. You can see average response time went to 2 seconds almost, and which is I think not good. It clearly shows that we are now getting a little bit of latency. And if I see although there is no failure, but sometimes back I was recording, sometimes back when I was testing it, I got some failures also, connection reset by P or something like that failures. And you can see still where our RPS is 35. It was kind of close to between 35, 40, something like that. But the main thing is still our median request is also 2 requests, like 2 seconds. Like almost 50% of our users will face 2 seconds of delay or response time, which clearly shows that it is now throttling a little bit, like lot. So I guess the sweet spot would be between 100 and 120 maybe concurrent users or one core CPU server. But again, it depends on completely the application itself. Here, this is just a very basic stuff. This is just to fetch the home page, and only these two operations are doing DB related operations, and that two very minor operations. So nothing fancy going on here. But one thing is that all my endpoints are asynchronous endpoints in Python. This whole application is on Django. So yeah, I think the sweet spot will be between somewhere like 100 and 120 for this server. And I hope you learn something. Thank you.